Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam there are two concentrated loads. 54 kilonewton. It acts at a distance of 2 meter from the left support, and 108 kilonewton. It acts at the distance of 2 meter from the right support. Length of the beam is given as 6 meter. We know that the upward deflection due to Rb will be equal to the downward deflection due to the loads. In this case, we can use this expression. This is the deflection due to Rb. This is the deflection due to the load 108, and this is the deflection due to the load 54. Now from the point B and about the point A, we are going to find the moments and draw the bending moment diagram. In this case, we have to follow left hand side rule. Clockwise will be negative and anti-clockwise will be positive. First, let us take RB. It is acting in the anti-clockwise direction, so that it will be positive, and the distance is 6. 6 into RB, we will get 6RB, and the diagram will be in the shape of a triangle. Now let us take the point load 108. It is acting in the clockwise direction, so that it will be negative, and the distance is 4. 108 into 4, we will get 432. Now let us take the point load 54. It is acting in the clockwise direction, so that it is also negative, and the distance is 2. 54 into 2, we will get 108. Now let us find area 1 x1 bar. We know that it is a triangle. We know the area formula of a triangle, half into BH. Here the breadth is 6 and the height is 6RB. So this is the area. Let us find x1 bar. We have to find the centroid distance about the right side. The formula is 2 upon 3 into B. Here the breadth is 6. So 2 upon 3 into 6. In this way, for area 1 x1 bar, we will get 72 RB. Now let us find area 2 x2 bar. For this triangle, the breadth is 4 and the height is 432. So this is the area. The centroid distance about the right side is 2 upon 3 into the breadth, that is 4. Also, we have to add the remaining distance, which is 2. So 2 upon 3 into 4 plus 2. For area 2 x2 bar, we will get 4032. Now let us find area 3 x bar 3. For this triangle, the breadth is 2 and the height is 108. So this is the area. The centroid distance about the right is 2 upon 3 into 2. But we have to also add the remaining distance, which is 4. So 2 upon 3 into 2 plus 4. For area 3 x bar 3, we will get 576. In this expression, we have calculated everything. Let us apply all of them. Finally, for RB, we will get 64 kilonewton. Now let us apply the rule sigma V is equal to 0 and find RA. RA and RB are acting upwards, so both of them are positive. These two loads are acting downwards, so both of them are negative. In this way, we can find RA, which is 98 kilonewton. Now from the point B and about the point A, let us take moment and find MA. RB is acting in the anticlockwise direction, so that it will be positive, and the distance is 6. So 64 into 6. This load is acting in the clockwise direction, so that it will be negative, and the distance is 4. This load is acting in the clockwise direction, so that it is also negative, and the distance is 2. Let us assume that MA is acting in the anticlockwise direction, so that it will be positive. Finally, for MA, we will get a positive value. That means our assumption is correct. MA is acting in the anti-clockwise direction. Now let us use the right hand side rule and find the shear force values. We know that in the right hand side rule, upwards will be positive and downwards will be negative. Here you can see the shear force calculations. Here you can see the shear force diagram. Now let us find the bending moment in the point A. For that we can use the right hand side rule. Clockwise will be positive and anti-clockwise will be negative. In the point A, we have MA, which is acting in the anti-clockwise direction, so that it will be negative. Now let us find the moment in the point C. MA is acting in the anti-clockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive, and the distance is 2. For the bending moment at C, we will get 40. We can find the bending moment in the point D easily from the point B. In this case, we have to follow left hand side rule. RB is acting in the anti-clockwise direction, so that it will be positive, and the distance is 2. For the bending moment at D, we will get 128. We know that in the point B, the moment is 0. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. We can make a section in this point and find the distance. You can see that in that point, I have made a section at a distance of x from the point A. Using the right hand side rule, we can find the moment in that section. We know that it is 0. Using that concept, we can find x, which is 1.591 meter. Let us apply that. Now we are going to end this session. Thank you for watching this video.